All right, so I'm going to go over W14, which is solving one and two-step equations, word problems, right? So if you have already started this assignment, you will see that you're only looking for an answer, right? And a lot of these word problems you could probably kind of do in your head, but what I'm going to do is I'm going to actually go through how do we write the equation, and then how do we solve it. So even though you're doing it in your head for some of these one-step equation word problems, you're having the same thinking process, all right? So first example, Adele takes 2 pages of notes during each hour of class. And in all, how many hours will Adele have to spend in class before she will have a total of 26 pages of notes in her notebook? So she's going to take 2 pages of notes during each hour. How many hours will she need to have 26 pages? So a lot of you might be thinking, oh yeah, we just can do 26 divided by 2 equals 13, right? 13 is our answer here, which would be correct. But if we were writing an equation here, it says she's going to take 2 pages of notes during each hour. So it's 2 pages of notes for every hour. So pretend if she had 8 hours, then that's 2 times 8. She gets 16 pages of notes. If she had 10 hours, then that's 20 pages of notes, okay? So H is our variable for hours. And now she's going to have a total of 26 pages. So this would be our equation where we can divide both sides by 2, and 26 divided by 2 is 13 hours, right? Which is kind of what you can kind of do right here in your head, mental math. But it's nice to know that we can write an equation from a word problem. So that's what I'm going to go through in this video. Just talk about some different things, because sometimes I notice kids see word problems and they see numbers and then they're not sure whether to add, subtract, multiply, or divide these numbers together. So if we can get ourselves an equation, then we see exactly what steps are required to solve it. All right, next example here says Ethan has already run 6 miles on his own. He expects to run 1 mile during each track practice. How many track practices would it take for Ethan to run 48 miles? What can we do here? Well, let's pretend we're doing this in our head. I'm pretending here, okay? So he can run 6 mile. Wait, 48. I see 48 here. I see 6 there. I know 48 divided by 6 equals 8. How many 8 practices, right? I'm sort of using the numbers and doing things with it, which is what I think students do if they're doing this in their head. What I'm going to warn you about, though, is that absolutely sometimes seems easy, but it's not. So 8 would be the incorrect answer, because how the word problems start is he's already run 6 miles. So he has 6 miles, and then he's going to run 1 mile during every practice. So it's going to be 1 mile for every practice, or 1p. So I'm just going to write p. How many track practices would it take for Ethan to run 48 miles? He's going to have 48 total miles, but he's already run 6. So if we subtract 6 from both sides, he's going to need 42 more practices to get to 48 miles. And that's because he's only running 1 mile every practice. All right, next example here. Nellie has already walked 8 kilometers this week. Ooh. So as I'm reading these problems, she's already walked 8 kilometers. So I'm going to write 8 kilometers. Then she plans to walk 2 kilometers each trip to school. So we're going to add 2 kilometers for every trip. Let's write two. Let's write S. I'm not gonna write T because it looks like a plus sign. Not a big fan of that. So every 2 trips to school. Or let's write capital T. That will solve it. Math people are problem solvers. There we go. So every trip, 2 kilometers. How many trips will she need to walk a total of 48? So the total is 48. She's already walked 8. She's gonna do 2 more every single trip. So it's a 2-step equation here. So let's use an inverse to move that constant to the other side. So positive 2t equals 48 minus 8 is 40. Let's divide both sides by 2, and she's going to need a total of 20 more trips. All right, word problems and word problems with multiple numbers don't have to scare us if we try to reason through it. All right, when ringing up a customer, a cashier needs 27 seconds to process a payment as well as 1 second to scan each item being purchased. All right, so cashier needs 27 seconds plus 1 second, so plus 1s, or just plus a second. If it takes 50 seconds to ring up a customer, how many items are being purchased? So subtract 27 from both sides. And so it's going to take 23 seconds, but because we know it's 1 second for each item, so it's also 23 items. Or I don't have to box the S part really. It's just 23 items there. All right. These do take practice. All right. So I really encourage you to, this is not a, word problems are usually not very fun. And although the assignment just asks for an answer, you can probably guess or do things inside your head. Practice on writing these equations. All right. Next one, Kelsey's birthday costs $3 for every guess. So it's $3 for every guess. How many guests can there be if she's going to spend a total of $42? So let's divide both sides by 3. And she's going to need 42 divided by 3. You can use a calculator to get 14 guests for her birthday party. All right, and finally, the last one. A person can pay $17 for a membership to a science museum. Okay, so $17 for membership. It's flat rate. Then go to museum for just $3 per visit. So $3 for each visit. 3V. What's the maximum number of visits for a total cost of $41? All right, so let's subtract 17 from both sides here. 3 visits equals 24. So let's divide both sides by 3. And for $41, they can visit 8 total times. All right.